Okay, next test. Can you hear me? Okay, next test. Can you hear me? Okay, sounds good. How's the volume of the music compared to the volume of my voice? Great. Okay, well, I won't be streaming long tonight. This is really just a test. It's so much easier using OBS to do this. Discord makes it a right flaff. Cool. I just went to click on the YouTube window to try and move my mouse in Engine. Okay, so right now the reactor doesn't work because I'm halfway through sorting out the fluid system, and I just wanted to check that fluids are getting through. So let's give the reactor a bit of power. Great, so we've got 10 litres a second coming out of the coolant, 5 litres a second going out. That's just an arbitrary amount I was testing with. That can actually just be the same amount because it's just a circuit. And then what I'll do is I'll increase the temperature as it flows through, so the outgoing coolant will be a higher temperature than the incoming coolant, naturally. And then we've got 10 litres of helium-3 coming in, and the same with deuterium, and then it stops, so that needs sorting out. And the reactor is currently non-functional. Right, so these buttons are working, or are they not working? No. So Just need to sort them out. And these ones should all be working. You're not working. Okay, so you need fixing. You're fine. Right, so the loop back needs fixing. And these three should be good. Yeah. So they are fine. Okay. Right, let's fix that one first. Okay, yeah, we just haven't actually added those yet, so I'll just add those in. So that's input 3 open, and input 3 close. Right, that's that piped through. So it should have the same code as that one. Okay, you're not set to that. Right, so let's take a copy of that. Whack that in there. And this is input 3, so we'll replace that one. And that needs to be input 3. And so it is that. And then we do the same on the UI. So not that one. We want that one. What was I going to call that? Oh, return. So that's the tank return. So we've got the relief valve, the refill, and the return valve. And it's that one that we need to take the buttons from, which we've not done yet. So let's add those. These guys need to go over here. So we've got the power. And those. Oh, other way around. Right, and you are input 3, aren't you? So it's input 3 open, input 3 close. Right, that takes care of the button handling. So that will fire off this event here, which in turn will fire off the rep notify, which will sort out the button state. Where are we? That one. Right, that comes through to this, and we've already got the input 3 added. Yep. Right, so that should be that button working now. Right, so that's U fixed, and then we need these two on this one. So there's the output valve, there's the input valve. Yep, and yep. That looks fine. Let's grab the widget. Right, so you're part of the electrical system, so I'll sort you out separately. So valve controls input, valve controls output. Okay, yep. Power ID, power. Oh yeah, none of them are hooked up. That would be why. Right. So what are we setting here? So input, that would be you. Ah, of course. It is a Blueprint interface now, so we're not firing off those events directly. Right, so I don't want any of you. Right, are we reporting the fluid device? No. Right, yeah, that's the other version of it. Don't want that one, we want that one. So that would be input, open and close, which is that one. So input open, input close, output open, output close. Right, okay. Right, so that takes care of the button presses. Those are the stat boxes. Yes, I can see you type. It doesn't help that I keep forgetting to look at the chat box, but I can actually see you type, yes. Right, let's give that a whirl. I very rarely stream, and certainly not on YouTube, so I'm still learning the ropes. In fact, I think last time I streamed was back when I was making the refit, which was quite some time ago. I've still got some of my old pause screens from that ready. At least I think I did. Do I still have them? I do. Look at that. so those UIs are not updating. And you're half updating. Okay. Weird. So input 3 open, input 3 close. Yeah. All spelled correctly. Input 3 open, input 3 close. Okay. Yep, so we've got the right variables. We've got the right string. Input 3 open, input 3 close. Okay, yep, that all looks fine. Don't need you for now. Don't need you, actually. Yep, that's fine. How weird. So are we defaulting all these to on? Yes, we are, apart from that one. Not that that matters, because they are being set here. Although input 3 isn't, but that shouldn't make a difference, because it's just the initial state. This is where we check to see whether we're in cold and dark startup mode, and if we are, this is what sets the various valve states. Yes, we only really want the output valve closed. Okay. Okay, so the other one that wasn't working was, get rid of the pipe, don't need that. Right, that was these guys. So yeah, that's fine. Input, output, open and close. Input, output, open and close. That should be you. Yep. Okay, so we're setting the right button states there and there. Right, okay. So with you, why don't we? Let's just stick a print on here, see what's going on. Actually, let's do it over here. So we want the button, and then state. Let's give that a try. Right then, let's have a look. So 1 0 0 1 1 0 0 1. Yep. Okay. Yep. Zero. 1. Okay, for some reason it's not killing that button when the valve's closed, which is odd because it's actually the same, literally the same widget, copy pasted. So the valve graphic's working, as is the light. Weird. What about these ones? Okay, so the valve is physically working, but it's not updating the UI. Okay. But it is stopping flow. I bet there's a typo on that somewhere. I'm assuming you're the same, yep. Now the weird thing about that is it's actually firing the button state, and it is sending the correct state, which is 0. So we're enabling the open button, and then we're disabling the close button. Although, is it only sending it the once? Hang on. So input 3 is open, input 3 is closed. Oh, I see the problem. It's because there's a D on the end. There we go. So that fixes that one. Right, that's better. That's why that didn't make sense. Do we have the same problem on this one? So open, close, open, close. And then on the pump hardware, we've got open, close. Let's get rid of some of this junk a minute. Right, so we know that's working because it is physically preventing the fluid from flowing. But is the rep notify working? I wonder. We know the pump display is working because we're updating the little boxes on it. So let's... yeah. Let's try this. So just grab you. I'll do the same for the other one as well. And let's get rid of the debug on this one for a minute. It's not needed. I noticed the reactor was spamming some stuff, so we'll turn that off too. Right, so we don't need that. I think the chiller was also potentially spamming some stuff out, so let's just get rid of that as well. Yeah, that, don't need that. know that one works. This one should now work. Yep. Quite sure why it's starting with them both on. I'll have a look at that. But yep, that works now. What about you? Okay, so it is firing the rep notify. That's working. Okay. Right. And you're starting off with both enabled. Okay. Okay, so chiller. 1, 2, oh, dur. That should be 3, and that should be 3. Right, that fixes that as well. Right, so you should be fully working. And let's figure out what's wrong with you. Right, so you are sending output open, and you are sending it to here. So let's just replace that. Yeah, it's definitely spelled the same. It's all connected up. And just to double check, we've definitely got the right reference. There should only be one copy of that anyway, so that probably wasn't the issue. But let's put in a, yeah, stick in a debug here. So button state. Let's see what that's doing. At the same time, we don't need that one. So we know that they're definitely working. So is it actually firing that? That's what we need to know. Great, yep, that's defaulting properly. Perfect. Right, now what about you? So when I click close, close is 1, open is 0. Close is 1, open is 0. Then that should be the opposite. Yeah. Yeah. Okay, so that is definitely sending the right information. Oh, hang on. Output sending input and input sending output. That can't be helpful. What did I do? Input, 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 input. Yeah. Yeah. Input, input, output, output. Yeah. Right, so input, 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 input. That's definitely all input. And then we've got input, input, output. Huh? Alright, well that's why that was doing that. But that said, still should have been changing the buttons. So if we do have our initial setup, yeah we do, so... Yeah, let's move this slot there. That just makes sure that we've got the display set up before we start sending things to it. Okay, so that should set the initial state. Okay, so I've got the right buttons now, but still not changing the UI. Okay, and it wasn't doing it on startup either, so... But we are definitely sending the right info across. So the question is, if that's firing, why aren't these firing? Now we know this works because it's the same code that's shared across all of the valve UIs. So if it works for one, it should work for all of them. But let's just let's put this debug on this again. Oh, hang on a minute. I am spotting something, maybe. Where is it? Lost it. Pump, right. So that goes there, that goes there. Right, so we're sending a blueprint interface to here. Now this is sending a blueprint interface. Right. Right, it's not actually firing a direct event. Which on here we are now actually doing. So that would be why that's not working. Right, because that doesn't need to be a blueprint interface. Because it already knows what class it is. Yeah. Button open, button close, get rid of them, duplicate them. Right. So we don't need that. And I'm confident we won't need that either. Right. That should be it working now. Out of interest, can you guys hear my game audio? There we go. Much better. Ah, great. Yeah, perfect, thanks. Right, so those valves are working. Those are working. Ons upstairs are working. So next would be these ones. Yeah, none of these are hooked up yet, so that makes sense. Right, so I need to sort out the outflow on these ones. I need to actually deduct fuel And I need to stop deducting helium here because we're not actually using the coolant, we're just heating it up. Okay. Right, so other than the power switch, you're working, so I'll get rid of you for now. Yeah, tank's fine. Don't need that. Don't need that. Don't know what I just closed there. Don't need that. Right, we do need that, and we do need that. Right. So going to assume I probably haven't hooked up any of those buttons yet. Yeah, so we need that one. That one. Okay, open. Close. Right, so that's the helium ones. This reactor UI is going to get quite big because we've got the whole fluid system and the electrical system, and whatever else needs adding to control both. Right, so that's the valve UI, we don't need that. That's the BPI, we'll come back to that. Right, so we need... Where's the reference gone? No, not that one. That one. So it should be fluid UI input. I think we're using the widget one. That's the electrical one. Yeah, so all of that's the electrical code, so basically we need the same again for the fluid stuff. Right, so there's the fluid in and out. So save my brain a bit of effort, I'll copy paste some stuff. Like all of that. So steal that. No, not there. Pop that in there. Okay. That will handle the replication of the widget buttons. And then we need valve states. So we need helium valve in and helium valve out. Try and be consistent with the naming conventions. What did I call them on here? Right, so let's go helium valve in. Open, helium valve in, close. That would be helium valve out. close, then helium valve. Out. Okay. I think we're going to need 12. Yeah, 12 on here. Okay, it's because we've got helium 3 valve in open, helium 3 valve in close. And the out equivalents. Right, so that should be all of our buttons. So open, open, open. Okay, and then the deuteriums. Yeah, I totally agree about the audio settings. I was trying really hard to get stereo mix working on Discord just so I could have some background music. But Realtek stereo mix is a finicky beast at the best of times. And so I tried using, I forgot what it's called now, this audio mixing software, and that didn't work either. It sort of worked, but the quality was bad, and I could also hear myself echoing when I talked, and that was really, really off-putting. So yeah, just sticking it on OBS on YouTube is just so much easier. Right, so this should be all of the inputs set up. So that should be all the button responses done. Now each one of these does need to be a rep notify variable because we need it to do stuff in multiplayer. Right, so you're all set with notify. Okay, which means you're all going to do stuff. But what stuff? Specifically, this stuff. So these need to basically tell the UI, one, that they've been pressed, and two, what states to set everything to. So we need a reference to the screen widget, and then we need to know which valve we are dealing with. So this would be helium valve in. Okay, yep. And we can just duplicate that on the others. Okay, so your helium valve up, helium valve out. So as I refine the system, I might very well convert most of this into macros. It won't hurt copy pasting it into each of the variables, but best practice is make it a macro. Write once, copy many. Okay, helium-3 valve out. Yep. Yeah, this fluid system has been probably one of the most brain-breaking systems I've done so far. And you'd think the electrical system would be the most complicated, but the problem with the fluid is fluid behaves differently. In an electrical circuit, everything's kind of instant. It's all working at the speed of light. But in fluid systems, you've always got this chicken and egg scenario where if you close a valve, then upstream would stop flowing because it physically cannot flow. But from the code side of things, you have to tell the upstream devices that flow has stopped. So you've always got this, you're always chasing your own tail. I think I've got it's running reasonably smoothly now, so it should be fairly difficult to break. But we will see once they put out a test build. Right, let's get rid of all of that. Okay, so we press the button. We then work out which button we have just pressed. We then set a replicated variable, which then updates the UI with what state the button should be. Okay, now all of these should be defaulted to true. Okay, however, I think it would be prudent just to set them. So we've got our cold and dark set up here. Okay, then we've got the widget being set here. Yeah, so really that's happening in the wrong order. So kind of want to do that first. So set the screen widget. Don't need that. Right, and then you need to happen after we've identified what the screen widget is. Okay, so how would you handle flow if a pipe downstream is shut off? value has a leak in it, i.e. but the downstream pipe still drained due to the leak. That is the most difficult scenario. So the way it works, if I open up the pipe a bit, so when the fluid passes downstream, so we're coming from the fluid source, it's going into the pipe and then into whatever device comes next. It performs the calculations here as to whether or not there's any leakage on that pipe, and the input volume, that's how much volume we're putting into the pipe per second, and that is set at the source and then flows down through the pipe, and then we deduct from that with our usage. So for example, with leakage, we're deducting from the input volume of fluid and we're adding it to the used volume of fluid. So when we exit the pipe and go to the next device or the next pipe, the used amount is going up and the inputted amount is going down. So we're using up that packet of fluid that's inside the pipe. So that takes care of leakage immediately and directly as it happens in the pipe. Now, once we get to the end device, we actually then we bounce back up the pipe again with a new signal. And what this is doing is this is determining, one, it reports the total flow. So this reports how much fluid was actually used. So whereas this is using the fluid, this is telling the sending device, so the tank in this case, how much fluid was used. So this is how we know how much to deduct from the tank. And this message will get through regardless of valves being open or closed, because it's just data flow. At the same time, it will report whether or not the pipe is physically blocked. So the one thing that it doesn't take into account right now is if you close a valve, then it will stop flow, because this variable here, flowing, will be set to false, and it gets set to false at any point on the downstream flow. So if any valves are closed on the way to the destination, this will flag as false by the time it gets to the end. So then the sending device knows flow has stopped, so the next tick input volume will be 0 because there is no flow. But the problem with it is if you have a leaky pipe and you close the valve after the leaky pipe, then the tank receives the signal flow has stopped because the valve is closed, but technically that shouldn't be the case because the pipe is leaking. So you can fix a leaky pipe by closing a valve after the leak currently, as it currently stands in the system. So that's the one scenario where it breaks. I'll code that out at some point, but for now that'll just be in there while we're testing it. That aside, every other scenario should be catered for that I can think of. So loss of pressure, loss of flow, all of that should just cascade through the system naturally. Yeah, I can't think of any other scenario where the logic would break other than closing a valve after a leak. But yeah, so when the build goes live and everyone's testing it, I'm sure we'll find another dozen problems. But yeah, for now, that's where we're at with it. And they're all circuits as well, so there aren't any dead-end pipes. They all flow back to their source. Actually, on that note, just to correct myself, because I forgot I updated this, this total flow value isn't actually used currently because when the fluid, because the fluid's in a circuit currently, obviously the input volume is being reduced and reduced and reduced. So whatever this is, by the time it gets back to the tank, is how much goes back in the tank. So we don't actually need to report the total flow because it's a circuit. This takes care of itself. This will come into play for things like the fresh water system, which won't be on a circuit. So you'll have pipes go off that are stopped and they hold pressure, but they have no flow when the taps aren't on. So that's when we'll use the total flow. So imagine a scenario where the end device is turned off and the pipe is pressurized, then the upstream valve is turned off. The end device thinks there's no flow and the tank thinks there's no flow. Assume then a pipe between the shut-off valve and the end-use device is damaged. That segment is segregated but leaking. Yes. So, hang on, let me get my head around this. Yeah, okay, so if we close a valve at the very end, then that pressurizes the system and there's no flow, but pressure's maintained. Okay, so if you then turn off the upstream valve, then technically pressure should remain in the pipe because you haven't taken that pressure away, which is the case currently, so it does retain pressure. So the end-use device thinks there's no flow. Yep. So yes, so the way it currently works is the end devices don't really care about pressure yet, they care about flow. So on the reactor's looking for a volume of fluid, not necessarily a pressure of fluid. That will probably change over time as we flesh the system out. But yes, so if you shut off an upstream valve, that will make anything downstream of that valve have zero flow, and that's all the reactor care about currently. It would also stop a leaking pipe, obviously, because there's no flow to begin with. Does that answer the question? I'm not sure. Like I said, this is a weirdly confusing system to build because just because of the way fluid behaves, it's weird. There are so many chicken and eggs. Yeah, so the segregated segment wouldn't leak as it currently stands because the input volume would be zero. So if the upstream valve is closed, there's no input volume, therefore there's nothing to deduct. So it can't deduct from zero. So there would be no leak. As soon as the upstream valve is turned on, it should leak, but won't if the downstream valve is closed. Yeah, we're not modelling air into the pipe. That's probably beyond the scope of what we want to simulate with the fluid. I mean, as much as, yes, we want it to be a fairly deep fluid simulation, there'll be a point where we think that's probably too deep. So pipes will leak, pipes will get blocked. I don't think we'll get as far as modelling sort of air intake. For the very next build, just for testing purposes, I will just leave them as cables. When it goes out for the live demo, yeah, there's no reason not to model the actual pipes. I wonder how many there are. So we've got 3 there, 4 there, so that's 7, 9, 10, 12, 13, 14, 16, 18, 21, yeah. So I'd say probably, yeah, because most of these pipes are going under the floor here and then popping up here, and then the rest of them are largely going to be running alongside the tank. So on here, so tank out. That'll be coming from underneath the tank, because that's the actual main tank supply. So that will come out from under there somewhere and go straight into the pump. This one's the one that needs to be routed underneath the floor, which goes across that way to the reactor. The input pipe and the bleed valve are both going to be on top, so there'll be two pipes coming down over the edge of the tank. And you'll have a whole bunch of pipes coming in and out of these guys, because you've got 3 in, 1 out. So for each of these, you will have another pipe running back from the reactor. So that's three pipes to the reactor, 3 pipes back from the reactor. So there's going to be 6 pipes running under the floor. And then I need to build a manifold to split the pipe for these two, because they're 2 shared tanks. Yeah. It shouldn't take too long, really. I've got a plugin in SketchUp which does pipes along splines, so I just need to draw the spline out, generate a pipe along it, and that should be that. Fingers crossed. I also want to finish modelling these stairs as well, because I keep trying to walk this way myself, even though I know the stairs are there. It's just kind of natural to walk that way. I was having a conversation actually with Claire about these stairs, because she was suggesting we have them on this side going down, so that when you're in the room you can see that there are stairs going down rather than them not being there. And obviously from down here you can just access them, but the chiller hardware kind of needs to be down here, not up here. So from that sense, it really does make more sense for them to be there. But I'll do them there for now. Yeah, and if that doesn't work, then we could look at just flipping them round 180 degrees and have them up here instead. But yeah, we'll see how it plays out in testing. Right. Okay. What was I doing? Right, I was doing this, wasn't I? So yeah, so we've got all our button presses, we've got all our button states. Right, now I need to reconcile these with these, which is these. Yeah, because they're all going to need renaming. Okay. And at the same time, we do need to set these as well. So I take a copy of that lot and I pop them up there. Yeah, I think it really depends on which way you're coming into the room. Because if you're coming into the room from upstairs, it makes sense to have them here. That just works nicely. But yeah, if you're coming in from downstairs, then it would be nicer if they were there. So it really is depending on where you're coming into the room. Yeah, so the chiller hardware, I guess in some ways Oh yeah, see, it would matter because the thing is, the chiller has got a heatsink which is exposed to space, and space is here, literally here below the floor. So the actual chiller hardware goes through the floor and is exposed to the vacuum of space. So just to keep it accessible, yeah, because if the stairs were going up from here, then I guess you still need to walk around to it anyway. But if you're up here, yeah, it would be more of a pain in the ass if you're upstairs, because you'd have to walk all the way around here, and then all the way down here, and then all the way around here to get to the chiller hardware if you were upstairs. Whereas having it here, you're not having to loop around on yourself quite so much. So in terms of foot flow, it actually does make more sense to have the stairs this way around. Yeah, that makes sense. Okay, so something we have to do here actually. So depending on whether or not the ship is cold and dark, the reactor needs to be configured slightly differently. So if cold and dark is not true, then the reactor is on. Otherwise it's off. Right, and then these guys also need to be slightly different depending on whether or not we're in cold and dark. So helium valve in can be off. Helium 3 valve in can be off. Deuterium in can be off. I'll leave the output valves on for now. So when you're doing the cold start tutorial, one of the things you'll be doing on the reactor is just turning on, or rather opening, the 3 fluid valves to start flowing fluid into the reactor. Okay, yeah. Yeah, let's see what the stairs look like when I've modelled them, because they'll be thicker and have lights on them, so they'll be a hell of a lot more obvious when you walk into the room. Okay, before I test this, let's just make sure we've got all these things named properly. So we've got helium in, open, close, helium out, open, close. Right, okay, so let's use these ones. So we've got helium in, open, close. Then we've got helium out, open and close. This is where most of my bugs come from. It's this a lot of different string switches and it's very easy to make a typo or forget what you were doing. Well, easy for me to forget what I'm doing, at least, with my scatterbrain. Just check those just to be doubly sure. Helium in, open, close. Helium out, open, close. Helium 3 in, open, close. Helium 3 out, open, close. Deuterium in, open, close. Deuterium out, open, close. Right, and hopefully that matches these. Okay, so assuming I've not typoed any of that, the reactor controls should have setup buttons now. Excuse me, coming through. Okay, yep. All the buttons are defaulting correctly. It's a minor miracle. They didn't work yet, but they are set up. Great. Okay. That's half the battle. Right, and okay, so that bit is set up, which means it will be here where he has these. Right, okay, so and then we know button IDs, right? So you are that one. Okay, that should be all of them. No, that's not all of them, is it? Double that amount. So yeah, so this, yeah, so this is helium out. some semblance of order. So helium-3 pipe in. Okay, yeah, that one. So that one. That one. Okay, and deuterium. Taking a wild guess at what my naming convention was. Was I that consistent? Oh, yes, I was. Excellent. Just making sure I've got that open and closed the right way around. Open, close. Open, close. Close, open, close. Yep. Right, so that should be all the buttons handled. Let's give that a whirl. Yep. 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 And yep. Great. Okay. Okay. Great. Okay, so the coil temperature is going up with the coolant valve closed, which is good. Comes back down when it's open. It should do the same here. Okay, so that's not reporting backwards flow. Okay, so that needs investigating. Alright, so if I turn off that valve there, then the reactor should be heating up. Yep. Okay. Okay. That should be the same. Yep. Okay, and then if I stop it flowing from the tank itself, it should also have the same effect. Yes. Good. Okay. Right, and now the coils should be cooling down. Thank you for checking, Lyra. Yep. Great. So I would say, other than that not stopping the flow, although to be honest, that shouldn't technically make it cool down. Yeah, I need some better teleports because Alt 6 takes me over here, which is kind of not where I want to be. I mean, Alt 7 I can use to get back down there, but I just run around aimlessly like the chicken. I was going to say that it still needs to use coolant when the valve's closed, but in actual fact that's not the case because the coolant needs to be a circuit, so closing the outflow valve should heat up the coils because it's not replenishing the coolant, so that needs fixing. However, the fuel doesn't need an outflow to work. It just needs to be pressure in the pipe. So the fuel can work differently. Okay. Okay, so when that comes in there, Okay, so that should be setting flowing to false. Okay, then that goes... Yeah, because that's not relevant, so that just goes straight into the intake. Right, and then we check that valve. Yeah, so that one is working. So that should already be reporting false from here. Because that's coming in on the out valve. I don't think this is doing anything weird, so... Yep, so we set flow to 0 if the valve is closed, pressure to 0, yep. It's fine. Right, so we don't need... Yeah, so the flow rate can just be the flow rate. That doesn't need to be adjusted. We don't need to deduct that. Because we're not actually taking away any of the coolant, which means we don't need to do that either. So we're just taking a note of the pressure, the temperature, and the flow rate. And then we're using that on the reactor tick. Okay. We're not sending anything out here, so that's all fine. Oh yeah, I see it. Thank you. I'll have a look at that. Oh, I see. Okay. Yeah, there's a number of different failure scenarios there. I'll go for each one later and make sure that we're catering for each of those. Okay, so other than that misbehaving slightly, I would say the helium system is complete for this. So that's a good start. Now we should be able to get the fuel sorted out reasonably quickly, and that should bring the reactor back online again. Alright, so helium-3 comes in, we do all the valvey stuff, that goes into the intake, right, and this is where we need to do our bits and pieces. Oh, I see what you mean now, yes. Yeah, I think for the most part, failures are going to happen reasonably instantly. So, well, I say that if there's a slow leak in a pipe, then that does need to decrease the pressure gradually. But it's not calculating yet the relationship between pressure and volume. I might need to do some actual fluid math for that just to get that right. But yeah, I will look into that. Right, let's set some helium-3 values a sec. So, where are we? Helium-3. So we want to set the flow rate. And this will be what should bring the reactor back online. So we need to deduct some fuel. I suppose ideally we are going to want to start storing the pressure and temperature as well. So let's just take that into account. So helium-3, oops, not like that. So helium-3 pressure, helium-3 temperature. We're not actually doing anything with the pressure or temperature yet, but we will set it for now, and then we'll do more with that later. So the flow rate, so how much literage? So I'm going to say, I guess, let's say 1 liter a second for now, which is probably massively more than a fusion reactor would actually use. But just for the sake of argument, let's just stick it at 1 liter a second. And then we can refine from there, just for testing. So this is helium-3, so actually, let's set it at half a liter, because deuterium needs to be double. So we'll set deuterium at 1 liter, and helium-3 at half a liter. Another thing we need to balance with this is that the tanks themselves are 100,000 liters, and they physically are. So one of the tools that SketchUp has is the ability to assess volume for a shape. So that volume is physically 100,000 liters. So we want the reactor to use a lot of fuel. Otherwise, that 100,000 liters is going to last a long time. So our reactor might need to be thirsty. Okay, that should be helium-3. Helium-3 outflow. I'm going to copy this for the sake of less to do. Okay, so that's the helium-3 output pipe. And then we're setting the helium-3 pipe out. Oops, that's that one. Set you to rep notify. And then you need to be a copy of that. So yeah, you need to be a copy of that one. It's helium-3 pipe out. And that is the helium-3 pipe actor. That one. And that would be that one. Right, okay, so that should take care of the helium-3. Now we'll just copy that for the deuterium. So deuterium pipe in, deuterium intake. Right, so we'll copy this one. Right, so now we just need some deuterium equivalents. So that's the deuterium flow rate, deuterium pressure, and deuterium temperature. Right, and set these to 1 liter a second. Oops. So this should give us our perfect 2:1 mix ratio, which means the reaction efficiency should be fixed, which it wasn't last time I tested it. So that needs to be that. Need to be replicated. steal this one again. Just for the sake of laziness. So that's that one. That's that one. That's that one. And that is this one. Okay, that's the pipe. And then we need deuterium pipe out fluid packet. Yeah, I'm not sure why it's lower. I mean, microphone's the same volume. I think this is probably just a difference between using OBS and using Discord natively. Right, let's give this a quick test. So I'm pretty sure the fluid report's not going to be working yet, so that will need to be added, but the interfaces should at least show some flow, and the reactor might actually just spring into life. Ha! Excellent. Okay. Progress. Right, so we're seeing 10 litres a second in, 9.5 out on the helium-3, which is what we expect, and then 10 litres in and 9 out on the deuterium. Again, which is what we expect. Okay, the reaction efficiency is still really, really low. Not quite sure why that is yet. I'll get into that. Now, if I close one of these valves, that should stop the reaction. Actually, start with this one because it's probably not reporting flow yet. Yeah, so I think those two can be closed because that's not affecting the input. But the moment I close this, wait, stop that. The moment I close this one, that should turn the reactor off. Yeah, there we go. And the same with this one. Yep. And it won't let me start. Okay, great. So fuel is being used. Okay, so on the tank then. Oops, missed the door. Okay, so the flow rate in is 19.5 because 10 litres per second is coming from the refill, which is always on. So that's just what we're filling the tanks with. And then the 9.5 is the return coming back from the reactor. And here it's a flat 20 because we've got 10 from the reactor and 10 from the refill. Of course, we've got 10 out here, then 10 back coming in here, so those two balance one another out. And then here we've got 10 out, 19 in, because we're using 1 litre. So that's fine. It's definitely recording the usage. This one, however, we've got 10 out, but only 10 back in because there's no refill valve for this tank. So that's the manifold that I need to make. And similarly, actually, both of these are outputting 10. But down here, what are we getting on the pump? 10. Oh, okay, because yes, because only one tank's actually connected, so I need to expand the pump UI so that it's got multiple inputs for the 2 tanks, and they can just both connect directly to it. I won't bother making a manifold. They can just manifold within the pump. Okay, so there's a couple of to-do list items. Okay, well, now that the reactor is back on, I'll do a build. So I'll end the stream here, and then I'll put a build out, and then you could have a play and see if you can break it and let me know if there's any issues. I'll stick it on the dev branch, and then I'll probably update experimental tomorrow because it takes ages to upload. But yeah, I'll stick it on dev. So thank you for watching this very first inaugural YouTube stream. I think it's all working, so maybe tomorrow I will do a proper public one for everyone to see on YouTube, and we'll see how that goes. So, next question is, how do I end the stream? Oh look, I could use my old graphics that I made for the refit. I'll have to make some new ones for StarSim, of course. I'll make something pretty I can use. Right, okay, thank you very much, and I shall see you on the next stream.